First, I would like to ask all the online guests to keep their mics closed and their cameras off. You have the opportunity to ask questions in the end of the defense. At this defense, the doctoral thesis of Juho Vepsäläinen, Master of Science in Mathematical Information Technology, will be presented for examination for the degree of Doctor of Science. Professor Tommi Mikkonen, the University of Jyväskylä, will act as the official opponent. As the official custos appointed by the Aalto University School of Science, I declare this defense open.
Honored opponent, esteemed audience, I represent Emergence of hybrid rendering models in web application development. I'm Juho Vepsäläinen. Maybe I tell a couple of words about myself before we really start. And before I really start, I would like to dedicate this session to my late grandmother that died a couple of months ago, but she knew that I would make it, so everything is fine. So about my background, I wrote my first website around 1998 or so. So that means I'm pretty old, but it doesn't matter so much. And the other point is that when I became more serious about web development, maybe 2004, and then more and more serious, I was a part of Webpack core team. If you know Webpack, it's a bundler that many web developers used at one point, maybe some still use. I developed Webpack merge. I published books about Webpack, React, helped to popularize these technologies, became Finnish code ambassador. And then something happened about 3.5 years ago. So there was a student from Aalto University, he sent me an email. He wanted to interview me for his work. And then at the end of this interview, what I did, I told him that, yeah, maybe I have some idea that's possible to expand into a doctorate, because I left academia over 1 decade ago. So then I was like, if I want the hat and the sword, now is the time to do it. Of course, later I found out that you cannot get the sword, but I'm happy with the hat anyway. So, but then it started 3.5 years ago because he was getting Petri in contact with me, and things started snowballing. You know how these things go. Anyway, now we are here because of one email, so thanks for the email. About the topic, maybe I explain the title a tiny bit. So originally I was supposed to study content management systems, but then, you understand it's too much, or there's maybe something more important. So I started looking into what we call hybrid rendering models in web development. So what this exactly means is that in web, we have servers, we have clients, we serve content from servers to clients. And I started to investigate different ways how to do it. So that's essentially what my work is about. It's opening an area of investigation for this specific branch. Because the way it works in my field, in web development, that we make things, but we more or less forget to tell others that we did this and that. So bringing science into this area of programming. About web, so web, it is the largest application platform. All of you have easy access. Most of the population globally has access to the web. So in principle, if you publish something, many billions of people can access your whatever you did. And we have this figure, $4.3 trillion, really big figure. That's the estimated revenue of e-commerce this year. So it means web is important, and because it's so important, it is important to improve it. So it's still growing as a platform, but at the same time, it is not that only the web that is growing, it's also the websites. So based on data from internet, I found they say in 10 years, the size of mobile web pages grew about 600%, which is really a lot. And of course, it's clear that images and JavaScript, videos, fonts contribute to this problem. And why is it a problem? Well, it is a problem that you encounter maybe even daily. So when you travel, you're in a train, you look at your application, doesn't load, it's slow. It is something that we can more or less fix, and that is actually a part of the reason for this work. And it is not only ourselves that we are annoying, we are also wasting environmental resources. So in my work, I looked into 3 questions. In the first one, I wanted to understand, like, how did we end up here? What were the developmental steps that were leading us to this moment? Because there were several reasons for this. Like, web is popular, but at the same time, it's in a way broken. In the second question, I looked into more specific techniques. So I was introducing several terms like islands architecture, disappearing frameworks, and resumability into the field of investigation. But we'll get into this a little bit later, what this means. The third one, it is from another angle. So I'm mainly looking things from the front-end perspective, but at the same time, the backend is important as well. So I looked into how to integrate edge computing into our workflows to create better websites and applications. In this work, I represent 7 papers. Actually did a little bit more, but 7 made the cut. So first, we have a paper about ECMAScript, how it became the dominant language of the web. In the second one, I discussed disappearing frameworks, like how they became a thing, why they're important. In the third one, I look even more detailed what these frameworks are about. In the fourth one, I was considering the combination of edge computing and static site generation. Fifth one introduces resumability and why it is an important concept that can change the way we develop web frameworks. In the sixth one, I looked at the big picture. What are the current performance optimization techniques? Because that's where you can find more research. In the seventh one, I looked into the combination of islands architecture and edge computing. But you can find all of this in the thesis. So if you like reading, read my thesis. Anyway, back to questions. So for the first one, how did we get here? So I found out that if you consider the success of the web, in my view, it's largely because of successful standardization efforts. Because with successful standardization, we were able to create a play field where many parties could contribute. And that, in end, was leading to these network effects. So it was easier to come aboard, contribute to the web, improve the standards, repeat. Another important point is that right now we have quite open web. So not so, I mean, of course we have closed platforms, but mostly open system. The third finding, it has to do more about architecture, especially islands architecture, because this architecture, it was sort of reinvented a couple of years ago. So we were attempting something like this several times in the past, but it is a simple and powerful idea that was formalized just a while ago. I guess the big finding, or not really finding, but observation, was that right now we have the single page application model, but maybe we can go a little bit further. There are reasons why single page applications are so common, but in the next questions, I will tell about the options. So in the second question, I look into specific techniques, like how can we go beyond single page applications. So I don't want to read this one question, so let's go to the content. Islands architecture, what is about? So typically what you have, I mean, consider a page. Some of the content doesn't really change. You can say that static. Some of the content is changing a little bit more often, and some of the content is changing all the time. So with islands, we can capture these dynamic portions of a web page, isolate these portions, and treat them separately, which is giving benefits in terms of development, caching, and so on. So essentially, we can simplify the way we develop websites and some form of applications. Another concept, resumability. So the background here is that in many of the popular frameworks, when you have dynamic functionality, what you're essentially doing, you deliver to the client, you deliver markup, and you deliver this JavaScript code that's telling how to make it interactive. So essentially, you're sending certain information files. And in my view, that's waste. With resumability, what we can do, we can send at least some of the initial information to the client and avoid work. Like in this tiny example I was sketching up, consider shopping list. So you will be sending to the client a list of things with names, with these tiny toggles that tell, did I buy the thing or not? And when you resume, you pick up this information from your markup and make your application interactive. So you didn't have to send this information twice, avoided work. Of course, there are some limitations to consider. You cannot simply always send all of the data, but consider this a starting point. So the main findings, if you consider disappearing frameworks, so disappearing frameworks compared to many contemporary frameworks, the point of disappearing frameworks is that it's literally trying to remove itself from your application. It's trying to ship as little as you can. So we try to minimize the amount of application code. The techniques I was just describing, are like ways these frameworks can use for disappearing. So essentially, we are challenging mainstream axioms related to framework development and simply try to do far less than we did in the past. And second point, with resumability, we can avoid certain work that we were doing in the past that simply doesn't have to be done. For the third question, that's related to edge computing. I looked specifically into incremental static regeneration and edge-powered islands. So what are edge-powered islands? Again, the same example as before with islands architecture, except this time you're serving these pieces from the edge. And what's the edge? So consider that let's say in typical architecture, you might have a server somewhere, anywhere in the world. You serve the content from this one server. In edge computing, you're actually dividing your backend across the globe into a global edge network. And then this network is able to serve content, run code close to the client. About incremental static regeneration, right? Okay, so this gets a tiny bit technical, but the point is that in the web, it is very easy to serve static content. It's very easy to cache. It fits. It's simply performant. But in reality, what tends to happen is that you have dynamic requirements. You have pages that change often, or something that has to be generated on the fly. Incremental static regeneration hits somewhere in between. So you get benefits of completely static while being somewhat dynamic. The main findings, first of all, islands architecture seems to combine well with edge computing So you get additional benefits. Incremental static regeneration. In my view, it's a good compromise between static and dynamic. And then, like this I was just scratching the surface. So I could go and write another dissertation because there's so much to be done. So so consider what to research next. What is the improvement potential for the whole web? How much better can we make the whole web if we decide, everybody decided, yeah, now if we fix our websites, what's the potential? How much of the web can be moved to more efficient approaches? Is there some way to automate some of this work? Because in practice, you cannot force people to go and improve their code. Maybe you can find better ways. And then third one, what is the impact of artificial intelligence? The funny thing is when I started, it really wasn't a thing, but then past 2 years, it is everything. So it really changed the landscape of web development. And then last, but maybe the most important question, what are the future paradigms for web development? Like how should we develop our websites in the future? That's it for me. Thank you. Sorry about that. It's a little bit technical issues here. So now the esteemed audience. Sorry about this. It's a little technical break. It's my first time. Sorry about this. Okay. I ask you, honored professor Petri Vuorimaa. Oh, sorry. We're really good at it. I ask you, honored professor Tommi Mikkonen, appointed as opponent by Aalto University School of Science, to present the observations that you consider appropriate for this doctoral thesis.
Colleagues, candidate, custos, others who are participating here. We are here to witness the doctoral defense of Juho Vepsäläinen, work being titled Emergence of Hybrid Rendering Models in Web Application Development. Well, as mentioned, web is the most powerful medium for sharing information and data across the globe. It's more than we have ever had. And furthermore, during the, little more than 30 years of existence, it seems to me that this platform has been constantly changing. So it started its life as a platform for sharing information only, much of which was very static. And today it is a real programming environment, and most of us run numerous applications out of it without ever installing anything on our own computer except the browser. That said, due to the ongoing evolution, I don't think we have reached the conclusion and the final stage of the web yet. Rather, we are constantly inventing new ways to make more out of its capabilities. And this thesis is a part of this road towards the better web for all of mankind. The results that the thesis presents build on already published articles that have been made available for scientific community previously. And I feel that there's a lot more to be covered by the candidate, and I can only congratulate selecting a field that is as fruitful as this one. So it is easy to see where the research could go next, and also that there is a tremendous potential to change the world. Then again, I have some detailed questions that I plan to ask next. Okay. Let's start with some warm-up questions. So why is this science and research not just advanced engineering?
So why is it science? Actually, that's a really good question. So I had this discussion with a French engineer, and he was more or less telling me that what you're doing, essentially you're setting up a framework that lets other people research the topic. So essentially we're defining terms, and when you define terms, you can apply for scientific funding. So when you can apply for scientific funding, you can do more science. So for in my year, that's one way to say science, that if you can get funded, it is science, especially scientific funding. That's how I see it.
Okay, so the answer, if you get scientific funding for it, then it is science. Maybe that is not the answer that I was expecting. So, the other answer is that I use established research methods, and I seek answers to research questions using those established methods for the next defense.
Of course, I mean that's the easy way out, but it's like
Yeah. Okay, you mentioned the research questions that you intellected previously. How much of that was built beforehand, like a hypothesis that this is something I want to seek in, and how much it was just trial and error? And
so let's put it this way: I'm intuitive person. So the first thing I did, I was writing this like a review. I was looking into the field. Maybe I should have published the first thing I did. But anyway, I did analysis on what has been done, what exists, where are the gaps. And considering I had 3 years, so I was able to find more and more gaps. And as I mentioned in the beginning, I wanted to look into content management systems. So I wanted to look into something else, but there was a topic inside the topic that felt more important. And at the same time, it was drawing me to study it. So it is just scientist intuition that was essentially leading to these questions.
okay, so basically you were doing things, and then you found out other interesting things to attack next.
Exactly, because anytime you discover something, then you notice there's more work to do, or have to be more specific, or I can go to that direction or that direction. Of course, you have always more questions than you can address. You have to be very specific that you don't lose your track.
Yeah. I would say that this is a typical thing for engineering type of research, where you are not studying the fundamental constants of the world, or trying to do experiments where you see if an apple falls faster in vacuum than in the air, and so on. It is rather building artifacts that teach you about building other artifacts and the building process.
Exactly.
Well, this also, since you can continue building artifacts forever, so did you have a definition of your done in your mind?
Definition of done, I mean, if you think about definition of done, we will have web that is fast and performant and not wasting resources. Of course, you can never reach it, but I mean, that's the whole purpose of this research, that how can we go towards a better world?
Okay. Then maybe if we step away from methodological side, because I don't think that is exciting for either one of us, and go into the technical part. And you've been saying that this is web all through the thesis. Why is it web and not just advanced distributed applications?
So why is it web? That's my box. Let's say for me, the web is about the specific standards. It's about the specific way of consumption. That, of course, underneath we have internet, but the web. So what is the web? HTML, JavaScript, CSS, search engines built on top. Of course, we have pages linking to each other and so on. But it's very specific thing in a way. We have clear definition what's the web. That's how I would separate it from the rest.
But come on, Edge is not part of the web.
Edge is not part of the web, but Edge it is part of the infrastructure enabling the web. So we have certain pieces under what you see as a client. I mean, as a client, you see some user interface, but to get to this user interface, you need something behind. That's where we have edge. That's where we have servers. So maybe that's a good separation. So you have the infrastructure level somewhere underneath.
But we are in this work mostly talking about, I guess, the client part.
Mostly client part. But at the same time, what I understood last year, that even when you're a front-end developer, the way you do your back-end work, the way you do your infrastructure, it actually has implications for your front-end work. So it is that front-end developers, they don't exist in a vacuum. They're affected by what's underneath.
Yeah. And also there were times, at least, when the limitations of the client was actually saying what kind of infrastructure you can use, like same origin policy and things like that.
Exactly, and I guess the important thing to keep in mind is that these days we have quite powerful machines. You consider developers, they're really, really fast laptops or whatever, they don't even notice the issues, and that's the issue. Really, that today, hardware is so fast that maybe we forget about the software that actually should be much more improved.
So how would you describe, when did the web become an application platform?
So when did the web become an application platform? That's, I don't have an exact date, maybe a year, around 2001, 2002. I mean, there was a starting point in time that I think many people missed it, but it has to do with browser development, because I think in 1998 or so, Microsoft introduced Ajax, this tiny API that lets developers fetch content from a website on the background, because before, what you had to do in order to move from a state to another, you had to more or less refresh the page, go to the server, but then now it was possible to do it without. So we didn't have to refresh to fetch new content, to update the page. That was the foundation for modern web applications. That you were able to perform operations in the background. And then that was leading to single page applications. All right, we got more web APIs, history API, and so on.
So basically you're saying that it was the XML HTTP request.
Exactly.
Exactly.
So
and Ajax, I guess.
Ajax, yes. That was the building block we needed. And then for a while, nobody noticed, but then people understood what you can do with it.
So what else needed to happen?
What else needed to happen? I think people needed to understand the power of this technology. So you started getting first examples, you started getting some formalization, you started getting libraries, frameworks around the idea. And we have been running this framework race now for, I don't know, 20 years. We are going towards something that's more suitable for applications, but at the same time we have this race at the standardization side, because in an ideal world we will not even need frameworks, because the web framework will be enough itself. So this is like two races in a way.
Well, you've been pretty careful in avoiding the issue of frameworks in the thesis. And I think that maybe that would be another thesis then, to study the evolution of the frameworks.
It is another thesis, but I think I'm happy with one thesis. So.
Yeah. So what were the first real web apps, in your opinion, then?
Actually, I don't have a good answer for that, because I didn't look in the specific examples of the first ones, but I remember maybe Slashdot had something. I remember reading that Slashdot was maybe the first example of using web in a new way. But and maybe we had this. It's likely that Google, some big companies, maybe Microsoft and others, had something like web application early on. But don't have a really clear picture of this topic.
Okay. What about the first single-page application?
I will push it to the same, because for me, single-page application, that's really when it started. They will not actually, no, let me correct. So first web applications, actually they come from the 90s. At the end of the 90s, we had this boom in e-commerce. Consider like Amazon, that is what we might say multi-page application, where you push most of the logic to backend. So backend is doing calculation and so on. So for me, the first web applications, they come from the 90s when people started building business on top of the web.
And then the SPAs are, well, an evolution of that where much when logic started to shift.
You can say it's an evolution in a way that it enabled people to create more complex applications. So before you were a little bit limited what you could do with this workflow that you have to go to a server, but with single page applications you could really start doing something that you expect from the desktop side of the fence. Because what happened eventually, web applications caught up, and now if you use a desktop application, might be even a web application, you just don't know it.
Mm-hmm. Yeah, I was trying to think what I believe is the first real web application, and I would say that it is Gmail.
It's very possible, yeah.
At least to me, it seems that it was one of the very first.
That is actually the interesting point is that like where you draw the limit between a website and web application. So where I ended up with my thinking is that you sort of have both. You can have a very big website that has portions that are application-like. So in real life, we're dealing with mixtures.
Yeah. I remember because I was also at Sun at that point, and we were doing web apps, well, web environment inside a web page. And at that time, Gmail came out also, and I also remember one of the drivers which was an essential ingredient, and that was the introduction of Chrome.
Yeah.
And V8 JavaScript virtual machine.
Exactly. I think Chrome was speeding up the development of the web a lot. Really a huge amount, especially with the introduction of V8, because before V8 the interpreters were quite slow, but now we started to get web browser that's really powerful and pushing things forward. And we received better web APIs, and then they had this idea that maybe we can do mobile applications, so on. So it really started expanding when big companies started to push money to it, and then you get competition and so on. So we had this feedback.
Yeah. I remember that the version that we had a mobile version of our web page, and in a standard, one of the Nokia tablets of that time in the early 2000s, mid 2000s, and the virtual machine was so slow that the clock would not tick every second.
Mm-hmm.
Whereas with Chrome, everything changed totally.
Yeah. I think it's not an understatement to say that Chrome changed the world. I think we will not be sitting in this hall if they had not done it. I think we will have something much different.
Yeah, if there was no Chrome, I don't think the JavaScript would have ever started to evolve the way it did.
Exactly.
Because it was there to change the image under construction with in numerous web pages, and that was it.
Yeah.
Yeah. What I was surprised is that you mentioned Visual Basic and Microsoft.
Yeah.
But you don't talk about Sun and Java at all.
Yeah, maybe I'm a tiny bit biased, but I mean, I might have forgotten a thing or two. Can happen, but it is. I mean, if I was writing it now, maybe I will remember to mention Sun. But it is like it's so easy to miss these things.
Yeah, because I mean, if Sun had done it differently and said that it's okay to use Java freely and for free inside the browser, we would not have needed JavaScript and things like that.
Yes, but I mean, that goes back to this point with Netscape and Brendan Eich and development of the first version of JavaScript. I mean, you have to ask yourself, why is it named JavaScript? It's marketing. It's nothing like Java, but they needed an environment to run in the browser because Java was too heavy. So you needed a tiny language that you can push the browser.
Yeah. And also, I guess that the JavaScript was not the language at all that Brendan planned to put inside the browser.
Yeah,
at least I've heard stories that he had a totally different approach, where it would have been more like small talk and
yeah,
like that, and then he would have to rewrite the syntax altogether.
Right. I mean, it will be very interesting to meet him one day and really ask what happened. But yeah, that's just how it worked out. I think he never meant that in 2025 visiting this whole discussing JavaScript, the most important language of our time, because it was like a joke language in a way, tiny language that you can do tiny things with, but it became much bigger than what it was supposed to be.
Yeah. Come to think of it, I actually found a paper called Using JavaScript as a Real Programming Language from year 2007.
Wow.
And I'm now, there is a part of this that talks about the different facilities of using JavaScript as a real programming language. And I'm going to ask you, well, not all of them, but some of them. And I would like you to describe the evolution of this particular aspect during the time frame of your thesis, or even beyond that, because you have this standardization thing.
Right.
So how do you see that things have progressed?
So things progressed. You mean with JavaScript standardization or the development of the language?
The practice of using JavaScript also.
Practice of using the JavaScript. So
let me first
yes.
point out the thing. Extreme permissiveness.
Extreme permissiveness.
You can do anything.
You can do anything. So if by that you mean as a general environment, I will do this connection between V8 from Chrome, because that was really the runtime you could run on your machine to access files, do normal operations. But it is, I think there were actually interpreters, general interpreters before V8 that you could run this on your machine. It was just with V8 we had something very much formalized, easy to use, performant.
But what I mean here is that if you I don't know, assign a value to a variable that you have never ever used and you never ever use it again, it's okay. And if you assign a variable that has no value, it's okay to use that. And nobody notices. And if you call a function that doesn't exist because you misspell the name of the function, that's fine. JavaScript just silently stops. So do you think that these features are still there, and what should be done?
So the problem with JavaScript is that because it was developed so fast, maybe some mistakes were leaking in. And the problem is that when you create a programming language for the web, it can be extremely difficult to change existing behavior, because if you go and change something, then you break the web more or less. So we are stuck with this, let's say, early mistakes or oversights in design. So it is more or less impossible to remove certain features from JavaScript itself, but at the same time, we have languages like TypeScript that more or less patch the language, form a shell around the language to let developers be more efficient. So you can always do something around it, but you cannot go and change the language itself because we are stuck with these past design decisions.
The second observation, lack of modularity and information hiding capabilities.
Right. So I believe this was solved with common JS modules. Yeah, we had quite early on, we had some idea. I don't exactly remember the exact year, but there was a clear need for module system, which was actually standardized, I think, 2015. So we had really official syntax for modules, but we had something before that. So there was a long time demand, and then standards caught up and finally gave us module system.
Yeah, you could, of course, implement your own module system, but if you have several developers in the same project, chances are that everybody implements it different.
Yes, there was something called, I think this was AMD, UMD. You could do this weird function-based things that I actually did myself or used the system. Of course, I would never use it's so ugly, but you could sort of go and implement a module system of your own on top of the language and make it work, but not very fun.
Yeah. Well, this goes on, and there are several ways to implement the same thing in JavaScript.
It is so.
And if you have several developers, you actually can easily create a mess. Is this still what is happening?
It is possible, but as I mentioned, that the world moved on. So we have actually most of developers, I mean, I believe, I don't know, but I believe they use TypeScript, which is making it a little bit harder to misuse the language. Doesn't mean you cannot misuse the language, but it's harder. So it is, if I was giving JavaScript to a team, it is even likely that they do some weird things.
Graphics and media.
Graphics and media.
Libraries were lacking at the 2007.
Yes, I think one of the, I mean, of course, you can say that you can draw more or less everything with the DOM, because the DOM was there for a really long time. But I think there's a turning point for graphics, I would say canvas element from the DOM. If you want to draw something in immediate mode, canvas, WebGL for anything more complex.
Yeah.
Actually, I did it, what, 20 years ago, I did my drawing application, but that was really when we received canvas element, then you could start doing proper graphics.
Yeah. Before canvas, I guess you could have used extensions like SVG.
Yeah, of course. And as I mentioned, you could do it with the DOM. So
with DOM also, but that's even more complicated. Yeah. Client-side JavaScript I/O model is complex and clumsy to use.
Yeah, it can. I would say it is maybe still true to some extent, but I mean we've received better primitives. So we have at one point we received promises on top of promise async await and better constructs. So it doesn't really completely apply today.
No support for unloading parts of a program.
Which parts?
Parts that you never ever use again.
Right. This thing. So
like like a disappearing libraries, but on the fly when you are running.
So essentially, the technique we are looking at is called code splitting. So what you want to do, you want to essentially, if you implement code splitting yourself, because if assuming you use web environment, then you're injecting script tags based on demand. So you have like a click handler, which is injecting a script tag that's loading code, that's executing, that's loading, and then you have more code running. But for this purpose, we have this what they call dynamic import in the current standard. I think it was maybe even 2015 standard. I don't remember, is it 15, 16 or what? But anyway, some years ago, we received syntax level support for this type of behavior.
Everything you load goes into the same virtual machine, and hence it can interact with each other.
Essentially, yes.
So what should be done to avoid this problem?
If you want isolation, for that I would go with web workers. Typically, everything runs in a single thread. But when you want isolation, you can push parts that have to be isolated to workers. That's how I do it anyway. So,
or iframe.
If you deal with the DOM in the browser,
yeah,
iframe, that's your sandbox.
Okay, then development style comments. You must use evolutionary development.
How do you define evolutionary?
You build a little, you try. You build a little, you try. You can't do like with the, I don't know, C++. And have 2,000 lines of code and then you start compiling and see how it goes.
Well, let's say that might apply for JavaScript, but at the same time, I think with TypeScript, I like my typing. I like to write my tests. I can write a lot of code in a single pass. It's not a problem these days, especially with tooling support.
Code coverage testing was difficult.
Not true anymore. I think you have, with the current tooling, you can see your code coverage. Because it simply, it was a tooling question in the past.
Yeah,
very hard, but we were fixing it.
This is totally fixed. completeness of applications is difficult to determine.
It can be because of this dynamic features of the language that make it difficult to like predict. It's actually a problem for interpreters because they cannot tell what's going, because they have to be able to like tell what's actually going to happen, so you can do more optimized code running and so on. But I would say it's a problem still today.
Well, it must be because it is a dynamic language, and you can on the fly decide that I'm going to call this function that has never been used before.
Yes, but at the same time, I think you can compensate with discipline, with good tooling, good libraries, runtime checking, good runtime checkers these days.
Oh. Event-oriented programming model.
What was the first word?
Event. Event-based programming model.
It's still
clumsy for those who learn to program by building this Hello World program.
So
maybe this is actually something that must change in our education system.
Well, we actually still use the same model a lot, but it doesn't mean there are no other options. You have good support for reactive development and so on. So there are options. I would say event-based programming, that's really the mainstream solution at the moment. Of course, good question. Should it be so?
No. Then there's a bunch of stuff about the virtual machines, which is not valid anymore, but one of the points is that if you end up using JavaScript as a multi-paradigm programming language, you create a huge mess.
You can do it. I guarantee you can still do it, but at the same time, I see, again, it goes back to discipline. So you have to choose the subset that makes sense to you and go with it. I'm actually a multi-paradigm programmer myself, so I use what makes sense for the specific problem. So I don't actually see that this is the problem. It's more like a strength that you can do things in a multiple way.
Well, it becomes a problem if you run a project where one guy writes small talk in JavaScript, one guy writes functional programming in JavaScript, one guy writes C in JavaScript, and one guy writes Java in JavaScript.
Yes.
And then you try to merge and make the code interact.
Yes, but I think you have to, what you need rules for specific portions of your code base. So you can tell, here we can use classes for this specific functionality, and on this part we use functional style and so on. So you need established rules. You cannot just let people do whatever they want, because then you end up in this situation you described.
Yeah, but this is a small contradiction to the fact that it is seemingly easy to start hacking with JavaScript and building the first features on the fly when someone is watching and saying that here's what's happening. And
it is so.
You actually need the design and the rules for the developers.
Yeah, and this is actually the reason why we have so much tooling around JavaScript to give us a little bit safety, and that is likely the reason why TypeScript became so popular, because it gave us even more safety. Of course, it's not the ideal solution, but it's better than no solution.
Okay, so pretty much much of the things have been improving, but there are still some holes left.
There are still many issues. Some we will never solve. It's even possible we displace JavaScript with something else. I mean, there might be a couple of options. Maybe WebAssembly can work as an option in some cases. And of course, from my point of view, maybe the real solution is that use less JavaScript, use the platform. Because the platform these days, it's maybe more powerful than people can imagine or understand. So when you use, it's like if you use JavaScript as your hammer, and you hammer with it everything, you make trouble. You end up with big applications that don't have to be big applications. So I will say, actually, the main thing, use less JavaScript.
Yeah, I can even buy that. I also feel that because computers are now so powerful, and because much of the developers that exist today have learned that okay, I'm gonna go for a library and import it here, and then you suddenly end up with I don't know, 2 million lines of code, and then you start wondering that now something seems going wrong. How can I debug this?
Yeah, exactly. So one of my co-authors, Misko Hevery, put it good way that maybe what happened is that we were emphasizing developer experience in favor of user experience. So we developed this tooling that is very convenient and you can create a lot very fast. And I would say today you can create even faster with this latest artificial intelligence tooling. So never before it has been as easy to develop a lot of code, but at the same time, what really matters in the end, it is what your users experience. So when they are traveling on the train, looking at your website or web application and cannot do anything, that's what matters.
Yeah. Well, reflecting back now, we already talked about this XML HTTP request, but what other steps would you think are important for JavaScript as a real programming language instead of scripting language, or the web as the platform for that?
So if I had to pick one, I would
say 5 steps.
5. I start with 1. So I think the most important, I will say, package management system. That for a while it was somehow tricky and complex to consume work created by others. And this is where NPM, Node Package Manager, became the dominant player. Of course, it was bundled with Node. I don't know if it was so smart to bundle it, but anyway, that happened. It became the standard for sharing your work with others. That was really one of the key things. And now the 4 other ones. Do you really want 5?
Maybe at least one more.
One more. So what made JavaScript a real programming language? Okay, this may be not the correct answer, but I will say developer tooling support. So very powerful development tooling editors, IDEs, something that you expect from environment like Java. Because if you write, I mean, you have written 1,000 times more Java than I have, but the point is that when you write Java, it's very easy to refactor code. You can go and just tell it, refactor this. And this is something that we have now with JavaScript, especially with TypeScript. I think that was really one of the points. And that's, for me, that's making it a real programming language that is easy to work with.
Okay, we already talked about this asynchronous request and Chrome, so that's 2. Package management, I can believe that, and then tooling. So one more.
One more. Any help? Yeah. It's a good one. What makes a JavaScript a real programming language? I think the fact that you can create really complex applications with it. If it was a toy language, you could not create what we have today. You can more or less do anything with it. And for me, that makes it a real programming language. Of course, because it's Turing complete. But I mean,
I would fully agree that it is the fact that the core language is quite small, but you have the power to expand it up to just about any direction where you want to go.
Yes.
And by moving the stuff from your application to a library and so on, you kind of expand the tooling that you have in building applications.
Yes.
Which is important. And much of the tooling or the libraries are already existing, so that you don't even need to do that.
Exactly. You don't have to do a lot of work to do something impressive. That's actually what I learned earlier this week at the conference, because I was following the presentations, and then I see that wow, you can do audio, you can do video, you can do something really hugely complex things that they could never imagine.
So that libraries would probably be also my big 5.
Yeah. It's likely in the big 5. Yeah.
So how do you see the evolution of libraries then?
So the evolution of libraries, I have thought of kind of two main views on it. So one, we have very strong libraries these days. You can more or less find a library for anything. But the second part, If you look at NPM, it has over 1 million packages. That's actually a problem. So I would be happier to have, let's say, 100,000 packages that are really, really good. So when you have 1 million, how do you know that your package doesn't have a security issue or doesn't have a problem, or like there can be something wrong? So more is not always better. My view is actually in my own work, I try to minimize the amount of dependencies. I was rewriting my web framework third time, and then I was more or less dropping everything, and I have only one dependency. So it is.
So would it be fair to say that this library selection has become almost like a fashion, that there are latest and greatest framework that people want to use?
You can say it is so, that it is like, it's a little bit, if you consider mainstream, you go with the mainstream option. I mean, I could say I have a solution that's much faster. You can use it to create better web applications, but that's maybe not a good pitch because you don't have ecosystem around my solution. So you have established solutions with strong support that's solving the other problems you need to solve. Because the many problems you want to solve when you create a web application. You need a design system perhaps, or you need this and that piece, authentication, whatever.
So how do we then should approach developing applications? Because, well, we've discussed that the frameworks are important, and sometimes when you pick the framework, you also join a community where you can ask help. And then at the other end of the spectrum, you are using a feature or a module that you don't know much. You have 3 different implementations that somehow compete with each other, and you have to decide which one to pick. And then you look at the popularity indexes and things like that.
Yeah, so, can I use the board? It's a little bit.
Yeah, sure.
I didn't do this for a while, so might not be so nice circles. Let's call this the platform. HTML, CSS, JavaScript. And the way I see it, this is what you want to use. You want to use what's in the platform. And this is the part you want to minimize. So this is your weird JS libraries and whatever. And what you call this, let's call it HTML first approach. There's actually manifestly called HTML first. The way I would develop any website or web application, I would look what's in the platform. Let's use that. For the rest, use as little as you can. Minimize this part. That's my approach. That's how I would create a new website, web application.
No, makes sense.
It's not a pretty picture, but
Well, they are almost round. Let's not stuck to the small details. Okay, so let's let the past be gone and start talking about the more recent events than the evolution of JavaScript history. So why did you pick rendering out of all the possible things that you could have done?
No reason. It felt like the right thing to do. It's just, I told you I'm an intuitive person, so I sort of go with the flow. Okay. Actually, if you look what has been done in the space, it is not so much. So that's your research gap. That's what you want to fill with your papers. I mean, sometimes it's a good idea to go where others go, but sometimes it's better to go where others didn't go and start building.
So how many rendering models there are in the web?
I cannot give you a figure, but it is at least 10. Let's put it this way. But next you ask a list, I cannot give you.
No, I'm not going to ask a list. I completely agree that there are more rendering models than probably we would need.
Yes, most likely.
Yeah. So which of them are you referring to as in your thesis as these hybrid rendering models?
So the way, I mean, you have the main ways. You have the client-side rendering, you have the server-side rendering. For me, what's the interesting part, the hybrid rendering modes are in between, like ISR. Like can I do something like that's a compromise. That's hybrid for me.
Okay. But which of the rendering techniques are you focusing on?
As I mentioned in the presentation at ISR, I would say resumability is an important extension, okay, a little bit related to rendering. Just considering what we render, how we render. But as I mentioned, so you have more or less anything else than CSR or SSR, and the space in between.
Okay. So when reading the thesis, I was wondering that how does hydration work in practice?
Okay, now can I?
Yeah, sure.
First to be a web page. Yeah, you can be a little bit boring maker to do that. So essentially, this is what we want to send to the client. So with hydration, actually what happens first, we send the markup. We send the markup for specification. But the question is, you have these buttons, you have to make this alive. So then we send piece of JavaScript. That's actually, it is this big here. It's captured, it can be captured the same piece of information, but telling that if you press this button, it's removing this. You have to actually send HTML, send JavaScript. And this is the double work I was referring to. You're sending the same thing twice, sending the baseline and sending the recipe how to make it interactive. This is hydration for me.
So do you see that with these mechanisms, I mean, this and resumability, you could actually implement a system where, well, how would I call it? Where the web page would be following you from device to device, like experience roaming from between the different terminals that you have in your use.
Yeah, that's a good one. How could I write a web application that follows?
Well, I mean, you start with your phone, then you, I don't know, go to the car, it jumps to the car computer, you go to the laptop, you continue there. And
yeah, I mean, the way, I don't know if it's the full solution, but the way I do it, I do query parameters. So I encode the state, the query, full data is here, and so on.
Yeah.
This is how I would do it, and the standard way to do it. So send the URL and resume a very left.
Yes, exactly. So this would be a way to do it.
Yes, this is how I do it.
And how quick would then the handover be? Well, I guess it depends on the web page size.
Mm-hmm. I cannot tell that. So it is. I mean, can you be? Maybe I get more specific. So what do you mean quick?
Well, how long does it take to do how much time does it take to do the handover from one device to another?
But that, of course, depends on the network conditions.
Yeah.
If you're on 5G or really on 3G or whatever.
So in best conditions, it would be almost instantaneous.
Yes, and of course, with something like WebSockets, it can be.
Yeah.
If you maintain have the client here, you have the server here, everything can be instant. You can literally have, if you have 100 mobile phones, everything can be instant.
Yeah. So in essence, you can think of this as that you have an agent that is constantly alive in the server.
Yes, that's
and then it jumps to the whatever display you have in your mind.
That's how it will work with WebSockets. Actually, now that I think of it, it's actually a good approach. Maybe I should write a paper about WebSockets.
Yeah, I was a bit wondering that you didn't have a paper about this because this is cool stuff.
it is cool stuff, but I mean, they told me you'll put 4 to 6 papers to your thesis, so it's.
Okay.
I would say compromise.
Then maybe a couple of words about the disappearing frameworks.
Yeah.
What is your motivation to simplify the amount of code that was not written by you? Or
So what is the motivation? It is essentially, it goes back to this left picture, that we really want to go as close to the platform as we can. It doesn't mean you cannot have a framework, but the point is that really minimize the framework. And the way I see it, you should have as little framework as possible. You don't want that the framework is owning all your opinions, everything. It really should be as thin layers as possible.
so what is the point in thinness? Because that's the smallest possible attack surface, or
That is one, but I think the main reason has to do with user experience. We are doing web applications for users, not for ourselves. But okay, that doesn't always apply. Sometimes we do applications for ourselves, but if you have many users, you want to serve them something that's standard, something that's fast, that's even good for money, because you make more money when you have faster sites. If you sell something, but it simply makes sense.
yeah, I can buy that. Then what about the islands architecture? How would you relate it to the micro frontends?
So the way I understand it is that micro frontends. So maybe the audience didn't read my thesis, so maybe I have to explain a little bit. But micro frontends. Now you make me draw again. So the problem is that we have space here. So micro frontends is actually about teaming. It's about software, how we develop software. What can this be? I don't know. We have this now. I mean, this starts looking like islands. But the thing with software development, I mean, you have this Conway's law that states that the structure of the software resembles how teams are structured. Or you can say maybe it applies the other way around as well. Well, anyway, the point is now you have team 1 doing this, team 2 doing this. Team 1, they like React a lot. Team 2 likes Vue a lot, and so on and so on. So you can, with micro approach, you can let the teams do whatever they want to do, more or less.
But you don't have to.
But you don't have to. You can, but you don't have to. But for me, islands, they're one implementation of this idea, because if you go with micro architectures, micro frontends, there can be a little bit more to this. Maybe like module federation, or you do some runtime magic or so. Islands, as an idea, is a little bit more simplistic. It doesn't really tell anything about like how do you have teams or not. Just that you have a slot where you can push your dynamic content. Okay,
and then the idea is that the different slots have different frequency of change, or
it can be. I think that's the direction anyway. That because if you look at the web page, these aspects share different lifestyles. Maybe navigation is more static, calendar is changing all the time, and so on. So you want, as a developer, you want control what we render and where and how often, and you get this cache invalidation, all that. In a way, it's about control as well.
So what does resumability introduce here then?
That's actually a good one. Does it combine or not? I guess it combines. Let's say it will be the recipient thing, or whatever. I have a list of things, because the way you go to islands is that they are more or less empty, and you load content on demand. with resumability, you could actually serve the initial content. So you would have a list of things or whatever. And then when you scroll to this piece, maybe you trigger some logic, make it alive. Only then. So there's some overlap, but you can use them together. But I think I didn't address this in the thesis. But I think it combines.
No. I also think that they are a good match.
Yeah. Could be another paper, but I don't want to read so many papers.
Then the one thing that I miss to understand, what do you mean by holotypes?
Holotypes. Okay, that's fun. So the way it works, I mean, I'm not a biologist. Maybe you have a biologist in the room, but you have birds. So you have your swans, you have your owls, you have your hawks, and so on. You have different types of birds that have different characteristics. The same applies for the web. You have different types of web applications. Let's say social media, you have something like graphical application that's really heavy. You have a blog. Yeah, I mean, there's this broad range of different types of applications we have. And these are what we call holotypes. And different holotypes have different requirements. Something can be more static, something has to be more dynamic, and something has to be searchable. For something, it doesn't matter. It is just one way to classify web applications or portions of websites, web applications, because I think in practice, most sites we have online, they're hybrid. So there is a blog, there's the e-commerce thing, there's the really interactive part. So that's how I think about holotypes. Well, why it was important for the thesis, because it gave me a way to classify, to see how something works in specific holotype. Essentially it's a tool for research.
Okay, because, well, I can understand the biology side.
Yeah.
But in computing, you can always build a missing link that is not an existing holotype. So yes, I accept that you can use it to categorize existing websites.
Yeah.
But it's not complete in the sense that there might things that escape.
Exactly. So it is not exhaustive, but it's useful. Useful is sometimes enough.
Well, I mean, somehow I think that you could have done the thesis without the holotypes also.
It is possible, but I think for this one paper, it was so useful.
Okay. I'll accept that. Then about Edge. How would you like to do this? Put a web server everywhere, or?
This is actually where it gets a little bit, I don't know, controversial or tricky in a sense that now I have to draw a picture. Tries to be the cloud. That's your Finland. I don't want to do the whole map. There's something. Anyway, in conventional way of doing things with the cloud, what you do, you go US East, that is one way. That's how we did it in the past. We will rent a cheap server from Amazon from US East 1, done. But of course the problem is now you have some distance, and we cannot escape the speed of light. So we get latency, and latency is not a fun thing for users. So essentially, what is more fun? We'll push one server to here or near or maybe Sweden. Put one here. Essentially, you minimize this distance. But of course, I mean, now you have a lot of servers. It's low latency. Of course, new problems. You have to replicate your content. Maybe these tiny servers there are not maybe so performant. So there's some trade-offs, but I think you can live with the trade-offs. Actually, one point I forgot to mention, it has to do with privacy. Do you want that your data is everywhere? Maybe not. So there are some problems to address. Essentially, with Edge, we address the problem of latency, which is really crucial for certain types of applications.
But by edge, then you don't mean edge in the traditional sense of cloud edge continuum. It's still...
Well, I think the way I understand it is that edge for the web, I mean, edge computing, it existed for a while. And the background is that we had these content delivery networks that work so that it will replicate the content like this. So you will have these servers around the globe. You will send the image from close to the user. But at one point, we understood that it's actually useful for web development, because we can run logic on this infrastructure. That was really the key point.
I would think that this is actually something that is going to emerge as a new research topic for several reasons. One being that the geopolitical atmosphere is a bit unstable.
Yes.
And apparently the Finnish politicians even have realized that they have made a deal with Microsoft that everything stays in Europe, but they have omitted the part of the American law that says that whenever US officials say that you must give us all your data, Mr. Microsoft, they will give all the data, be it in Europe or be it elsewhere. So it is going to fundamentally change how we think about these systems. And,
Yes.
Okay, latency is a good technical motivator, but I do believe that these new European directives like Gaia-X and EU AI Act and Data Act and the likes are forcing us to reconsider that what legal implications does this, in your terminology, edge architecture have?
Yes, I think I will even expand on this. So now, if I was writing a thesis right now, I would maybe write the paper about this like a local first software, or like what you want to push data to the client, because the basic assumption of cloud computing is that the data is somewhere in the server. It doesn't have to be so. It is enough that there's some kind of way to synchronize.
Yeah.
So it can be that in a couple of years you see more this type of software that turn everything upside down. So data belongs to the client, you lose liability. You're not liable for some data breakage because you don't have the data, nothing to break.
Yeah, I think that this gives a rise to a totally new type of a paradigm, because previously you have had the application somewhere and you have delivered data to it.
Yes.
And in the future, you have the data somewhere secure and you have to be able to send applications to process the data.
Yes, so I think we will rethink the way we build software in the next years, I hope.
Yeah.
But there's interesting motivation by certain vendors to keep it the way it is. So there will be some maybe political fight, and you will need new tooling, new frameworks, but it's already happening. So I can see it
happening. Yeah, and it is also changing how software is being done, because you need to be isomorphic in the sense that the same application has to be able to run in different kinds of environments.
Yes.
Where the data happens to be.
Yes, and there's like one more thing. You can even end up in a world where you don't even have user interface anymore. You just serve somehow data or functionality and let the user construct the user interface. Like, because so many web applications are not very good, so why not to make it well once and combine it with data and call it a day?
Yeah, for sure. Like headless web applications where you don't have a UI at all.
Yeah, but it actually might be here already with MCP, but I think it goes too much outside.
Yeah, I fundamentally believe that we are going to need those kinds of applications.
Yeah.
And that's a good topic. All right. What about the contributions? So your requirement, research question 1 is what led to the dominance of single-page web applications and what are the limitations? How would you characterize that?
In terms of contributions, I think.
What is your answer to this question?
So what was leading to the current state? Well, as I mentioned in the beginning lecture, the background is that we really had strong and successful standardization efforts by multiple parties that we are creating this playground where others could contribute and build their business. Because when you have business, then and money attracts money and development, and that was leading to this, like the emergence of single-page applications, and then we had this explosion in frameworks, at powerful frameworks that let you do more or less whatever web applications you might like to do. So that was sort of the, I would say that's the main point I have in mind.
Mm-hmm. So how much do you see these disappearing frameworks, Iceland's architecture and resumability will help? They
help, and you can already see that they are making an impact with frameworks like Astro, because like Astro, essentially they have islands out of the box. You could implement islands on top of anything, but when it's already integrated, you really don't have to think about it. So it is already making an impact. Mm-hmm. Of course, you can ask how big the impact will be in the end, but something will happen for sure. I'm not so sure about resumability because it's a little bit niche idea, but it feels like a good idea that should be explored more.
And finally, research question 3, what is the effect of edge computing in the big picture?
I think it really comes down to latency and pushing the data close to the user. And the other fact is that you can, let's look at this picture here. If you have islands, you can more or less have a single worker on the edge matching this island. So it's even good development-wise. You can divide your functionality on the back end or edge. Nice for development.
Then about a couple of questions about the boring part of the research, and not your results per se. So how much time have you spent on measuring things? I mean, clearly I can see from the articles that you like to build stuff.
Yeah, I like it.
Then evaluating that and doing the measurements, how painful is that to you?
How painful? Well, I not very painful. I built these things for a long time. So it is. I cannot tell amount of hours. I have the amount of hours, but you have to give me 5 minutes to figure out the amount of hours. But it's. I don't see it as a problem to build. I mean, the main problem is that you should not end up something that's too synthetic. Because if you have something that's too isolated, I mean, isolation is good, but at the same time, you should try to capture what's happening in the real world.
So what proportion would you say you have spent in doing the measurements and evaluation in comparison to the active development?
Really cannot tell. I cannot tell. Let's say 10%. That sounds fun.
Okay. Good. What about the other boring thing, the literature review?
You mean the thing I did in the beginning that I didn't publish?
Well, I don't know when you did it because it's kind of not present in the thesis at all.
It is missing. I think it must have been, I don't know, tens of hours. But you sort of have to do this kind of work again and again. Things change, you get new papers. So it is, you cannot say that, okay, I did the review. I have to keep an eye on things. Of course, I was delegating these things to my students, so go and research that. So, because for me, it was extremely good way to learn more about the topic to work with other people, because you should not do this type of work in isolation.
Okay, yeah. But you know there is a risk that you end up working in a bubble and not see what others have done.
Exactly, but that's why you need to work with other people, so you are, not in the bubble. Other thing you can do, run a conference, because that's really expanding your bubble.
Yeah, okay, yeah. Well, this is a part that you could have done better,
Of course, it is so that I will do many things in a different way now that I know how to do things.
Okay. Then what about the making yourself visible? So do you think that the forums where you have published are the right ones for the papers, or would you have liked to publish them elsewhere?
I guess the main problem is that don't really have too many options. And I'm a pragmatic person, so for me it's better to get the papers published than get them published in the best possible publication. Because if I aim really high, I will be still at home writing something.
So what would be really high in the context of web?
I think I would really look into this. ACM has really good conference. I think it was called web something. I really forgot the name, but
The web conference.
the web conference, and there was some. Was it ICWE or ICSE or what?
It is pretty good conference
Yeah.
to go on.
They actually tried to submit somewhere, but then it always doesn't go through. Almost always, but not always.
Then going back to what you said in the beginning, that how did this? Well, I was kind of expecting to reading a story about how one thing led to another in the thesis, but it's not very clear there.
No.
What was your research process like?
Maybe not so linear, because it is. I think quite early on, I did a draft of the dissertation just to understand what are the gaps, what am I missing. I think it was a good idea to do it quite early, because that was showing me that's where I have to add more material, and that's where I have enough. Because again, you don't want to publish papers that you cannot use. You have to be a little bit specific about it.
Okay, so like having an outline of the thesis and then figuring out
Yeah, you have to figure out what's missing.
Yeah. Sounds good. So why did you do all this? So, and I have multiple options here. So the option one is that you wanted to change the world. B, bring knowledge to the world. C, to get a PhD. D, because Petri and Aalto forced you to do this.
Yeah, I guess it is somewhere between A, B, and C. And there's a reason I cannot tell in public, because then I would offend somebody.
So how did you know that you were done? You had the 7 papers and that's it, or?
I mean, that's why I have the professor. It's like...
All right. Maybe final question. If you were now starting over, what would you do different?
What I will do, likely everything. So it's like, it is just so that I think I'm now in a spot where it will be comfortable for me to go and publish something independently. And I'm doing some collaborations. I know what the expectations are. But and the other point is maybe I could not even do this topic anymore because world moved on. So it's a different world now.
Yeah. And that's the benefit and threat in this field that is moving so quickly.
Yeah. But I think it's good that I got it done, because as I mentioned, now I made some French guy happy that can get research funding.
Yeah. All right, so let's go to the final statement. Yeah. Mr. Juho Vepsäläinen has defended his thesis on the development of web applications, associated positive and negative aspects and the way forward. The thesis mainly reports practical results, aiming at solving real-world problems and understanding the root causes that are being fixed. While the methodological part of the thesis has been addressed in a somewhat shallow fashion, the publications and the papers included in the thesis are providing clear results that are, in my opinion, very genuine and authentic in the sense that they show that the candidate is able to do research in the field of software engineering. From the scientific point of view, many of the results are not fundamentally groundbreaking because, well, there are attempts to do the same things, But at the same time, I think that the significance comes from the practical and applied nature, where I clearly see benefit and new results in the work. Moreover, the results form a reasonably coherent whole that introduces knowledge that did not exist before and demonstrate that the candidate has all the capabilities of being an independent researcher on further conducting research. During the defense, I find that the discussion has been great. You have been able to convince me that you have done the work yourself instead of someone writing everything in the margin and then having you defend it. And yeah, it has been a pleasure being here. Based on the above, I have no hesitation whatsoever to recommend that the thesis and the defense are accepted, and Mr. Juho Vepsäläinen is granted a doctoral degree.
Thank you so much. Then now I cannot remember this last part. I have to read it. Sorry for this. I'm not really professional at defending. Esteemed audience, I ask those of you who have observations to make on the doctoral thesis here presented to kindly request the floor from the custos. So if you have any questions, please.
I agree with your approach, but there's a threat to it, and I wonder how you would address it. If you were a mid-level browser like Google, and you could run it on the web, you could look at the heaviest, most popular libraries in JavaScript and put them into the install of your browser, together with proprietary features that distinguish it. For example, we currently load very large JavaScript libraries to subtract the background in video calls. And they could add a feature that makes them the best by far option to that, which then makes them on the web. There's a very real instance of this where OpenAI has said that they would really like to buy Chrome if Google is forced to sell it. So there's the threat actor right there. Your approach is minimize the libraries by using as much of the browser API as possible. So that makes you subject to that threat. How would you handle it?
So how will I handle that? I mean, so I mentioned I run this conference. Maybe all of this has to vanish, and maybe we need content API. You have your piece of content, and here this user that is generating a client on the fly or doing something completely custom. So maybe we simply go to mass customization, which is likely a good idea anyway, which you cannot do today. But this will be sort of, I don't know if it answers your question, but I think this is really the direction that we get away from static web towards something like that we rethink what are websites, what's content, what do we sell, how do we provide it, so on. But yeah, as you mentioned, it is now we have this like monopoly in the browser department, which is maybe not the best thing. Maybe it would be better to have more competition, and I hope Firefox will be stronger, but yeah, cannot get everything.
Any other questions, please?
Yeah, can I ask a question from candidate, which is a bit beyond the scope of the thesis? So thank you for this thesis. But it goes a little bit to the same direction. You mentioned earlier that the web developments have been or will be challenged by these emergence of AI now, and you probably would have done many things if the AI would have been earlier available in the same way as it is. There are a lot of similarities in the AI and in the web. So they are both networks, they both can be managed somehow mathematically similar. But what is then the power game now? If web is kind of a data, where AI is a technology which will then somehow manage the data in web, which of these, first of all, what can we learn when we are developing AI? The mistakes that we should not done, that could have been or had been done in case of web. And the second is that what will be the end result of this power game between the web companies and the AI companies? They are partially the same, but still, how this thing will evolve further.
I think I will try a combined response to The way I see it, okay, you have this, AI companies, they push their technologies, but at the same time, there's like a counter power in terms of open source movement. So I think it's extremely vital and important that we have this, let's say, AI engines, LLMs, in the public, in the open, so that developers, companies, they can review what has been done. I think you cannot leave something important like this to only companies. Maybe you even need some regulation in the space to push towards openness, because it is so important topic. Because as I mentioned, we were lucky with the web that we essentially have an open web, but maybe there are other options could have ended up with some other completely different configuration. And my hope is that with these latest developments, we end up in a similar situation, that instead of having to use open AI solutions just to live in the world in effective manner, we have good options. And actually, I think open source will power this. I mean, I'm ideologist because I did open source for 20 years, but I mean, that's how I see it, that maybe European unions will push because they're good at pushing, so.
If somebody online wants to ask, you can just open your mic or type in the chat. Any questions from here, audience, please?
Yeah, about standardization, maybe a short question, but standardization happens, web API standardization happens basically between browser vendors and from Mozilla. So it's only browser vendors, but no one from universities or the.
Well,
can you think of ways how we could contact more universities or get more feedback from that side?
Well, so I work a tiny bit with TC39, TG5. They have this group. You can join. Anybody can join. So it's actually, I had this bachelor's thesis done, but he found out that if you look at CSS, HTML, ECMAScript, the process is somehow open. There are some parts that are a little bit shady or not shady, but a little bit closed. But in essence, anybody can contribute. And maybe now that I think of it, we could do more at the university side to, get more involved, get the students involved. I think what you propose is good, that we cannot let others decide for us. We have to get a little bit involved.
Okay, it seems that online people are not able to unmute their microphone. Sorry for that, but you can type your question in the chat. I can then repeat. Any other questions from here?
Yeah, maybe talking about the privacy and security topics. So, do you see that the platform and standards have everything that is needed for the next generation of applications, which maybe the data leaves the clients and there's just synchronization, or do we need some standardization steps?
So what tends to happen with standardization is that when you have a topic that sort of that a solution is needed, but you don't know which solution is needed, you have competition. Like with these web frameworks, is that they do something that's not possible to do with the platform. Best ideas maybe find their way to the platform. So essentially you have this diffusion of innovation from the developer side to the standards, because when you have standard actually fixing things, you make it more complex to change, which is not good if you standardize the wrong thing. You have to be a little bit careful what you standardize. So I don't think we have all the pieces we need yet, but maybe in a couple of years we're closer to what we need, and maybe in 10 years you have, like, let's say, a synchronization standard for local first software or something. Might happen.
Okay, we have one question online, so I repeat it. What do you think how the web energy consumption reduction could be researched and approached in general? Thinking of possible solutions/hypotheses, would promoting AI web generation for simple websites producing static output instead of current standard WordPress for web hosting companies be one potential way?
It's simple answer. We can measure it. So I'm actually with a good friend of mine. We're doing this measurement. It's not public yet, but what we found out it's a research space that's not so much explored, especially in the front end. We know what's happening at the network. We know what's happening in the back end. Information about front end is sort of missing, but I think we can more or less show the benefit of the new approaches. But of course, one thing is to show the benefit. Another thing is actually to make impact, because most people, they've never fixed these things. So I think another.
Yes, there is another question regarding energy efficiency. The disappearing frameworks reduce both computation and transit costs, while the island approach allows using several different frameworks, in essence multiplying the computation and transport costs. How this should be addressed?
I don't know if there's actually anything to address. I think I have to look at this picture again. So one thing I really didn't explain is that when you have islands, when you have a big web page, but essentially what you do, you expose what you call strategy to the developer. So you say strategy when it's visible, for example. So then you load the island only when you need it. So of course you don't get the all islands at first. You can get them on demand. So I don't see harm in using islands. I think this is much better than setting everything at once. So that's already like one step towards the right direction. Is not maybe the destination, but it is better than what most people do already. And if you want a good example of a framework that goes beyond islands, look at Quick, QWAK. So it is, yeah, but I don't say it's like a bad thing to use islands or you get issues with this. Of course, now we cannot argue because he's not here.
Okay, any other questions from the audience, either here or online? Okay, don't see any questions. I would like to remind that anyone besides the opponent who intends to make an official observation about the doctoral thesis shall give notice of this intention at the defense. Otherwise, that person loses the right to make such an observation. Any observation about the defense shall be made to the department within 2 weeks of the defense. On behalf of Aalto University School of Science, I would like to thank you, Professor Tommi Mikkonen, for acting as opponent. I declare this public examination closed.